Welcome to our Biosafety Cabinet 101, Foundations for Safe Handling of Special Pathogens. This is presented by NETEC. NETEC's mission is to set the gold standard for special pathogens preparedness and response across health systems in the U.S., with the goals of driving best practices, closing knowledge gaps, and developing innovative resources. This is done across several treatment centers across the nation. We have 13 regional treatment centers across our different HHS regions. NETEC leverages the knowledge and experiences of its regional partners to produce timely and innovative educational resources, provide technical consulting and assistance, build a nationwide special pathogens resource infrastructure, and convene global partners. With that, welcome to our Biosafety Cabinets 101 webinar. I am Vicki Herrera, which I forgot to mention at the beginning. I am a laboratory work group chair for NETEC. And today presenting, I am very proud to present Corey and Tefero. Corey currently serves as the Director of Biosafety at the University of Texas Medical Branch in Galveston, where she also holds the roles of Institutional Biosafety Officer and Alternate Responsible Official. With over 19 years of experience, she is a seasoned biosafety professional recognized for leading world-class biosafety programs in high and maximum containment laboratories, biosafety training programs, select agent research programs, and biosafety operations across academic and healthcare settings. Corey is an active member of the UTMB leadership team and serves as a biosafety liaison to the UTMB biocontainment unit. So what better person to present on this topic? So Corey, I'm going to turn it over to you. Thank you for being here today, and the floor is yours.
Thank you so much for allowing me this opportunity today. I wanted to start just a little basic, starting about, I know we're going to talk about biosafety cabinets today, but, where do they serve that role in biosafety and biocontainment? So everybody has seen the hierarchy of controls here, and we utilize often engineering controls when we aren't allowed to either eliminate or substitute the hazards. So why are biosafety cabinets such a vital resource here? They offer a unique engineering control where we can, often depending on the make and the model of the biosafety cabinet that you are using, offer the three pillars of protection. So where it is allowing us to protect not only the person or the worker, but our surrounding environment, and also, when needed, protection of that product that we are working inside the biosafety cabinet with. Biosafety cabinets are an enclosed system. They are ventilated, and they allow this safe workspace for manipulations of infectious material or potentially infectious material to be manipulated. This is really a primary way that we can achieve protection. Today, we're going to focus mainly on these engineering controls. What are other ways maybe that we provide containment? So we can achieve containment in several different ways, mainly breaking them out into two separate things, such as primary and secondary barriers. Barriers are created when we can really create like a separation of either, the environment or the person and the hazard. So we can achieve barriers or make barriers by using PPE, or engineering controls like equipment, but also really importantly, our facility features. So primary barriers are what directly protects the worker from the direct exposure of that material that we have a concern about. It often is creating a nice separate area where the source is on one side and the worker is on another. And we can provide this in many different ways. Often we will see biosafety cabinets in the laboratories. We are familiar with safety centrifuge, cups and rotors, O-rings, and then PPE, of course, in that hierarchy of controls. PPE is way down at the bottom as far as controls that we would like to rely on. Now, when we're talking about secondary barriers, these are the things that are one step out from your primary barrier. So this is going to be, what are we using to protect the community? Not only the external environmental community, but what about my neighbors next door to me or in a different laboratory? It also is there to protect other people close to us inside these facilities. And these are often relying on facility infrastructure, such as HVAC controls or how these facilities are designed and constructed. We're utilizing directional airflow in some areas. And then the laboratories, depending on that biosafety level, have varying levels of what that facility should look like, whether we should have sealed laboratory penetrations, surfaces should be non-penetrable, things like that. One of the most common things that we utilize to protect not only ourselves as workers, but the environment are HEPA filters. For HEPA filters, so this stands for High Efficiency Particulate Air Filter, HEPA for short. And what a HEPA filter is made up of a really long continuous sheet of fibrous media. And it is then folded back and forth with aluminum separators inside to allow a little bit of room. But what it does is create a really large surface area for particulates when we are utilizing air to force this directional airflow through the HEPA filter so that these particulates can then be attached or run into, and we'll talk about different ways that happens, but can be, filtered out and removed from the air. So there's many different ways and a combination of ways that particulates can really be removed from that air, such as inertial impaction, straining, interception, diffusion, electrostatic, and often a combination of these methods. It is really important to know, what do HEPAs not do for you and what kind of protection do they not give you? And so it is important to know that they are not going to help with vapors and gases. These are for biological aerosols and particulates. So going to be important when we kind of talk about some of these ventilated equipments today, where that worker or community protection may not be available in certain types of equipment. Now, when we talk about ventilated equipment, you may see and have seen many different types of equipment in a lab or clinical setting. And so I would like to go through some of these today, importantly, so that when somebody says, why can't I use a chemical fume hood, or why can't I use that isolator? I don't have a biosafety cabinet. You have some knowledge to help do a risk assessment. Is it appropriate to be manipulating in a different type of ventilated equipment for the samples that you may have? So we're going to start today looking at biosafety cabinets, because that's what we're here for. But it is important to understand, what are the breakdowns? What are the different types of biological safety cabinets, and where do they fit, in alignment with these other pieces of equipment? Biosafety cabinets are broken out into 3 classes, class 1, 2, and 3. And then under class 2, we have different types and subtypes. So we're going to talk about all of them, but it is important. Most of the time, and the most common one that we see in a research or clinical environment is going to be a class 2 A2 cabinet. But we will talk about the other subtypes as well. So why do we like biosafety cabinets so much? Depending on which biosafety cabinet you use, they can offer up to 3 pillars of protection. These biosafety cabinets can protect the users, depending on the type and subtype that you have, by creating an airflow barrier that provides a unidirectional airflow away from the user and into the cabinet. Now, in some instances, when we talk about other types of ventilated equipment, we're going to talk about why the user is not offered protection. So we'll talk about what those air barriers look like. Now, the sash, this is the glass part in front, also acts as a splash guard. So it also can offer that type of protection as well. In some instances, we have a sample in the cabinet and we need to also protect the sample. So maybe we don't want potentially room contaminated air flowing over our sample inside the biosafety cabinet. So biosafety cabinets for some types have a perforated opening in the front where the room air is actually sucked down into the cabinet so it doesn't go and flow over your sample, allowing you to also provide sterility of that sample. And this can be important, on the research side and clinical side for cell culturing, but also on the pharmaceutical side when you need some sterility there. Now, we also can provide environmental protection. So we are working with maybe potentially infectious samples in the cabinet. And how do we protect ourselves, because we're in the lab, but also the environment as well. So we'll talk about the airflow patterns in these biosafety cabinets and pieces of equipment, and what does that exhaust air look like, and how is it filtered. Now here's just kind of a quick overview of the different biosafety classes. So just looking at classes 1, 2, and 3, showing that filtration that may differ, and then also the type of protection. We're going to go through these one by one, but I love tables and quick cheat sheets, so I made lots of tables for today. So let's start with class 1. So a class 1 biosafety cabinet can often look like maybe a Class 2 biosafety cabinet if you're unfamiliar with what to look for. So the important part about a Class 1 is that there is user protection because there is directional airflow into the cabinet, and there is environmental protection as well because the air that is exhausted from the cabinet does pass through a HEPA filter. But what it does not offer, since the air coming in from the room does just travel straight over the work surface, it does not offer you product protection. This ambient air is going to go just flow straight in without any filtration before hitting the product. So this would not be ideal to work if you are concerned with sterile or aseptic technique. It also is important to note that the airflow is driven because the biosafety cabinet needs to be connected to your building exhaust, and that is what is doing the pulling. So Class 1 biosafety cabinets do need to be connected to the building exhaust in order to function. Now, where we do see Class 1 sometimes are if you maybe just have some aerosol generating equipment, like a centrifuge or a vortex, where you're not worried about sterility, putting that piece of equipment in a Class 1 glove box at least provides now worker protection and environmental protection. But it should not be used for things that you do require sterility. Now, what about Class 2 biosafety cabinets? These do offer all three pillars of protection. And this is, like we said before, the most common biosafety cabinets that we see in BSL2s, 3s, and in BSL4s as well. So what kind of protection is offered here? We're going to talk about the directional airflow. We're going to talk about face velocities in a minute. That's what differentiates some of the subtypes. And we're going to talk about the recirculation patterns. Is air recirculated back into the cabinet or is it exhausted out of the cabinet? And then just a note on the last column, there are some cabinets where maybe minute amounts of chemicals might be okay. And then there are cabinets that are meant for volatile chemicals as well. So, but this is very common when we're talking about biological work and worried about where we need product protection, but also user protection, environmental protection. So starting with Class 2, A1 and A2. So what is the difference between an A1 and an A2? You'll often see these just get lumped together when people talk about biosafety cabinets, and the reason being, the only thing that really differs on these two is the face velocity requirement of the cabinet. So you can see at the bottom, the A1, the minimum face velocity is 75 linear feet per minute, where on an A2, it is 100. So why is that important? It can equate to greater personnel protection with a higher face velocity. So often A2s are used for more, stringent microbiology practices where you do want to offer a little bit greater personnel protection. Now, there are airflow patterns. So for the Class 2 biosafety cabinets, we're going to have that perforated, in the front of the cabinet where the room air is going to come in. It's going to be sucked down underneath the workstation, underneath the work tray. It's going to circle, if you follow those purple arrows, all the way up. And then what you're going to see is a pattern for recirculation and exhaust. So you're going to have 30% of the air is going to pass through a HEPA filter and back into the cabinet over your product. And then 70% is going to pass through a HEPA filter and then be exhausted from the cabinet and be recirculated potentially back into the room, or you can have a canopy or thimble connection, which I'll talk about on the next slide, is also an option, especially when you're talking about maybe there will be some small amounts of volatile chemicals used in that cabinet. This is where that hard ducting or thimble canopy can work in your favor for that. So when we look at the ducting of the biosafety cabinets, you can see on the left-hand side, this is a hard duct. So this is sealed. So the air that has been HEPA filtered passes straight into the building exhaust. So the HEPA filter is protecting your, house HVAC system. And then if you look on the right-hand side, you'll see that you have the building exhaust and then you have the canopy right below that. And then you'll see that there's an opening there, like an air gap, where the room air will pass through and up into there. So that's where you're drawing in more air, offering a little bit more protection for that worker if there are chemicals in that cabinet and it's not recirculating back into the room. Now for Class 2 B1s, these also need to be connected to your building exhaust. And then the difference here is going to be between B1 and B2, how much air is recirculating and exhausted. So for B1 cabinets, we are looking at 30% of the air is going to be recirculated back into the cabinet. It'll pass through a HEPA filter and then provide you clean air in the biosafety cabinet. And then 70% of the air is going to be exhausted out of the cabinet and not returned to the room. So when we get to class 2B cabinets, here's where we see that if you do have a combination of, I have, biological hazardous materials, and I maybe also need to work with small amounts or minute amounts of volatile chemicals or other radionucleotides, this is where these cabinets are more appropriate for that type of work. Now, the difference between the B1 and the B2 is going to be, like I said, the air circulation pattern. So for here, we are circulating 0% of the air back into the cabinet, and 100% of the air is exhausted out to your system. So there will be a spot on the top of the cabinet where it does need to pull in room air. It'll go through a HEPA filter, still providing you with sterile air inside the biosafety cabinet. Now, understanding where that air curtain comes down and splits can be important for your work. Help you kind of maximize your work area where you should be working. We'll talk about that a little bit more at the end. So lastly, in the class 2 section is a class 2C1. And this is really a little bit newer than the other cabinets, but it is meant to be a flexible system, and it's a hybrid really of an A2 and a B1 or a B2 cabinet, where you can almost change the mode of it. So it can recirculate or it can be ducted. On the C1 cabinets, you'll see that there is like a deep pressed workstation on the work surface that allows additional airflow around that workstation to provide more protection for the worker. So it allows you, maybe when you have more procedures that require minute amounts of maybe volatile chemicals, then you can put it into the mode and you can offer more protection there. So there's a drawback maybe to this. Maybe it does limit maybe your work area in the biosafety cabinet, but again, is a nice new biosafety cabinet that can offer you that flexible kind of mode of depending on the work that you're doing in the biosafety cabinet and what your needs are at that time. So again, we've gone through class 1 and class 2 quickly, and then we're going to look at class 3s. We don't see a lot of class 3s. They are common when we are working, especially in BSL-4s, where we are intentionally sometimes generating aerosols. But I figure it is good to go over these because they can sometimes be confused with isolators. So a class 3 biosafety cabinet is a completely gas-tight enclosure where we are working through glove ports. Now, you do have HEPA supply coming into the cabinet, so the air is clean. And we have 2 HEPAs in series on the exhaust before it leaves the cabinet, so that the air also leaving is filtered as well. Now, the only thing with a class 3 is the air, once it's in the cabinet, there aren't these nice like airflow patterns. And so the air is very turbulent once it is inside the biosafety cabinet. So if that is a concern, it may be part of your risk assessment for why you may or may not want to use a class 3. But the other thing I wanted to note, well, the other classes that we've talked about have very specific certification standards for NSF certification. Class 3s are not part of that standard. So if you do have a class 3 and you have a certifier, they may ask, well, what are the certification standards? And what we follow are manufacturer provided standards for certification. So just a small side note there. So looking at the airflow, you can see air comes in with the green arrows, passes through a HEPA filter, again, kind of turbulent, inside that cabinet, and then air passes through 2 HEPAs in series on the way out. And class 3s are almost always customizable, and so you can see varying degrees of complexity in class 3s, so they can look a little overwhelming sometimes. Now, if we line all of these up side by side, just very basically looking at airflows, this is just a good side diagram to just kind of summarize what we've been talking about. So you can see on the class 1 all the way to the left why that air is not offering any product protection. So we're drawing in room air straight over our work surface, still providing though environmental protection and worker protection. When we get to the class 2s, we can see that we definitely have sample protection and worker protection. It's going underneath the workstation, going through a series of HEPA filters, either to recirculate back into the cabinet. Again, you can see when it gets down to the work surface, there's that split. When we talk about safe work practices, right in the middle of that split on the workstation is ideally where you want to place your samples that you're manipulating. And then when we get to the class 2C1, you can see depending on which mode you're using it in, it may operate in a variety of either recirculating back into the cabinet or exhausting out of the cabinet. And then lastly, the class 3, working through glove ports, HEPA in and HEPA out, essentially, for those cabinets. Now, we talked about biosafety cabinets very briefly, but what about those other things, right? People say, I have a hood in my lab. Why can't I use a hood? And then you should say, what kind of hood? So maybe you have a chemical fume hood in your lab and you're like, what's wrong with it? It has a sash, there's airflow. Why can't I work with my biologicals, or should I work with my biologicals in those cabinets, right? So a chemical fume hood's main primary purpose, right, is to protect the user from chemicals and vapors and things when they are manipulating chemicals inside the chemical fume hood. Yes, the sash does offer some splash protection and a physical barrier, but there is almost never a HEPA filter in a chemical fume hood. Most often we see them direct connected to an exhaust. I've seen chemical fume hoods that you can order that do actually recirculate back into the room, but it's going to require appropriate filters, whether they're charcoal and things like that. But there is almost never going to be a HEPA filter in a chemical fume hood. So if you are worried about the biological agents that you're manipulating, and does your risk assessment say it's okay if we do exhaust these out to the environment without any HEPA filtration? But that's based on a risk assessment. So it is important to remember there is no product protection, and then there's no environmental protection here for biologicals. Now, I hear a lot of people will say sometimes interchangeably use laminar flow with biosafety cabinets. And yes, biosafety cabinets can have laminar flow. They don't always equate, though. So this is an enclosed workstation that does have a laminar flow to it. And sometimes these are even on, biosafety cabinet stands. So you can see how somebody might be confused. It looks like a biosafety cabinet, right? But it's not always the case. So it does have a HEPA filter, but what we are concerned about when people choose clean benches, it's not for personal protection or environmental protection. They're choosing it because it offers product protection. So it creates a really nice, clean environment for your sample to be manipulated in a positive pressure environment. So it can offer you very nice particle-free aseptic area to work, but just know that the airflow is going to be blowing directly out of the cabinet towards the user. So it does not offer any type of user protection. So for horizontal, so you have horizontal and you have vertical, and the only difference really is which way is the HEPA filter and which way does the air flow through the HEPA filter. So for horizontal clean benches, the HEPA filter is located at the rear of the cabinet. And you can see on the picture on the left-hand side that arrow. So HEPA filter is there, air flows through it, and then just blows directly at the user. If it is a vertical clean bench, then the HEPA filter is located at the top of the biosafety cabinet, so air is drawn in through the top of the biosafety cabinet, passes directly through the HEPA filter, and then to the cabinet and at the user. So horizontal, we usually see for sterile equipment, maybe electronic devices. For vertical, we usually see very common for PCR hoods and PCR prep in that. So it is really important to know that for the clean benches, we should never handle anything in there that we are worried about being potentially infectious. Cell culture, you don't want any of that stuff being blown out towards the user. And then lastly, isolators. So there are many different types of isolators. So we don't want to confuse isolators with the class 3 biosafety cabinets that we talked about earlier. So in general, these are also, though, enclosed and sealed, and we're going to work through glove ports. But the extent of sealed can vary depending on the type of isolator that you're working in, and can either be configured in a positive pressure manner or a negative pressure manner. So it's going to depend on the sample that you have in the cabinet and what is the goal of that product, right? Are you trying to maintain a sterile environment, or do we have, hazardous materials that we need to contain, but also maybe have some sterility with those as well? So we have positive and we have negative pressure isolators. So for positive pressure isolators, these are really meant to protect the product from any contamination from the environment. And how it serves is it will have maintain an internal pressure that's higher than the room. So this we'll often see with GMP manufacturing, or maybe if there are FDA requirements that need to be met for sterile, safe operation of products. Or for aseptic isolators, these are really meant to be completely contamination free. We'll see these when we need to do sterile filling or in pharmaceutical processing. Maybe we're manufacturing gene therapy products and things like that, where that aseptic technique is absolutely critical. Or you can have a compounding aseptic isolator. We see these in pharmacies where they need to compound and it needs to be sterile, but the product isn't hazardous. Now, when we look at negative pressure isolators, we are now talking about operator protection and environmental protection. So we're going to maintain this by having a internal pressure that is lower when compared to the room pressure. So this will protect operators and the environment, and often is going to be used with hazardous or high-risk materials where we do need to be concerned with the operator. So you can also find compounding aseptic containment isolators as well, where you need to have protect the workers from hazardous sterile drugs during compounding. So isolators can be tricky. There are many different kinds. This is really just a high level kind of overview of that, just to bring awareness that just because it's an isolator, it may not be offering the type of protection that you think it is, and to look further into that type that you have. Now, if we just do like a really high bird's eye view, not into the nitty gritty of each category, here's just kind of a high level view of when I'm looking at these different ventilated pieces of equipment, and then looking across, what might each equipment offer me as far as protection, or what does that airflow direction look like? So this is just meant to be kind of a cheat sheet for people. Now you may say, man, how do I know? I have this thing in my lab, but how do I know what it actually is, right? So how can I verify what I think I have? So often you will find, you might have to look around on the equipment, but you should be able to find the manufacturer has a sticker or a plate. Some biosafety cabinet manufacturers just post it right on the front of the cabinet saying, you know what, this is a class 2 A2 cabinet. Some you might have to look down below the workstation, sometimes a little bit to the right or to the left, and look for this sticker where you can see, oh, that's the model number, and oh, there's the class. Look, it's a class 2 A2. And then you can also find out whether it meets NSF standards as well on those cabinets. And then what should I look for when it comes to certification? So certification stickers are going to vary at every entity. We all have a sticker that we like, and we all maybe do things a little bit different, but maybe what are some things that are helpful from a user perspective? So when should biosafety cabinets be certified? So they should be certified at the time of installation, and then at least annually. However, I want to say that is centric to the US. So please be aware if you are in, international sites, this is just not always the case. And sometimes they're based on risk assessments. So again, talking about the US here. Now, what about in between that annual certification? What if I move the biosafety cabinet and it's not a cabinet that's on wheels and meant to move? That could require certification, and often does if it's moved a certain amount of inches. Or what if the cabinet maybe had certain repairs that could potentially affect the certification, filtration efficiency? If I moved it, did the HEPA filter get dislodged? So there are other types of things that may require that to be recertified. Now, when I'm testing a biosafety cabinet, and not me in particular, but the greater we, does that mean that the HEPA filter has to be changed every time? Absolutely not. So what we're doing is we're just testing the efficacy of the filter. HEPA filters treated nicely can last a really long time, 10, 15 years sometimes. So you're not required to change the HEPA filter, but you are required to make sure it is functioning as intended. Now, what about UV lights? Some people love them and some people hate them. And if you choose to use them, that is okay, but we should understand at least some of the limitations and maybe some of the maintenance of those UV lights. At UTMB, when biosafety cabinets come in, the first thing we do if someone did order the UV light is take the UV light out. There are uses for UV light. So it is important to know the mechanics or the safety interlocks of your equipment. Newer equipment often has an interlock where if the sash is not all the way down, the UV light you can't even actually turn on, and that's just a safety mechanism. You should also check to see, does your sash actually offer the UV protection that people need if they are in the same room as when the UV light is on? Not all of them do. Now, how does UV light work? So UV lights can be good, but they only are effective on things that are exposed in the direct line of sight of that bulb, right? Or that UV light. So if you have boxes or papers or there are shadows in the cabinet, it can't go around that, right? It can't go through it. So there could be, dark areas in the cabinet that aren't going to be exposed to the UV light, and maybe people think they are. You should have a maintenance schedule for that bulb. So you will lose effectiveness from the UV light over time. I've seen some procedures where UV lights are replaced, every 3 to 6 months. You do need to make sure they're dust-free and clean, and then just really think about what does that replacement schedule look like? And then really think about, why are we using the UV light? Hopefully it's not to serve as a primary disinfection method. Hopefully it is a secondary disinfection method where, yes, we've wiped and disinfected everything down, and we're just going to turn it on for, DNA and RNA degradation, those sort of things. So do think about why we are using UV lights if we're using them. And do know that if you do leave certain material inside, it will deteriorate, especially certain plastics and things that will break down, pipette boxes and things like that. So thinking about material that might be in the cabinet. Now, we don't have a ton of time to talk about safe work practices. And if it is an interest to a lot of people, we are thinking that it could possibly be maybe part 2 to the webinar. But I do want to talk a little bit about, a lot of questions that we might get are, well, how do I know what I should do in a biosafety cabinet, especially in the clinical setting, right? So how do we decide what do we do in the cabinet and what can I do on an open bench? Or maybe, point of care at the bedside. So it's important to, again, a risk assessment is really important, especially an entity-specific risk assessment for a few reasons, right? Let's talk about maybe sample types. Do we have unknown specimens that we're worried about? Are we worried about, maybe we do point of care testing at the bedside, maybe it's in a separate room. What about if we do have a suspect HCID patient, what are we comfortable with there, right? So let's think about what's the agent of concern if we know it, and what does that transmission look like of that agent? So if I have, contact agents, maybe versus respiratory, what are the chances that maybe the respiratory virus, there is virus actually in the blood sample? What does it look like maybe if I have an NP swab? What sort of procedures do I have to do in order to really prepare that sample in the lab for testing? So this is not really cut and dry, and it takes a good risk assessment. But in general, if we're just talking about general, what should we do in the biosafety cabinet? Anything that really generates an aerosol. So you can generate aerosols by uncapping samples. Of course, obvious things like vortexing, centrifuging if you do not have safety cups. So that if there are not O-rings in that rotor, then you can move the centrifuge, if you can, into the biosafety cabinet. That's fine. In some places, right, unfixed, human products, and you're going to do flow cytometry or cell sorting. Maybe slide preps of certain types of samples that you have to prep. What about if I have to vent blood culture bottles and I'm worried about this patient having something highly infectious? And then maybe point of care equipment, if you have the ability to do that. Not everybody does, and maybe bedside or benchtop is going to be appropriate in your situation. Now, prior to starting work, first thing we should do is really verify that biosafety cabinet, right? Or equipment that you have. Is it certified? Is it within date? On some of our stickers, we also write the magnehelic reading at the time of certification. Why might that be important or useful to a user? We want users to notify us before something actually fails. So if I know the pressure of the magnehelic at the time of the certification, if I start to see it becoming more resistant, then maybe the HEPA is being loaded, and maybe we can get that fixed before it fails. Or if I start to see a pressure drop going the other way, then we need to be concerned about, is there something wrong with the integrity of the HEPA filter? And before it becomes is that air being HEPA filtered properly, we can address that. Now, if your biosafety cabinets are not running all the time, which often they are not, you do need to check your manufacturer's specifications for what the recommended time is from turning on the blower to when you should wait to start work. This can be model specific. So in general, though, people will usually say 4 to 5 minutes once you turn it on. And then we should check for any indicators on the cabinet. Indicators vary very widely. Some are digital, some are not. So really be familiar with your cabinet and what you should be looking for there as well. All work surfaces in the biosafety cabinet should be disinfected with an appropriate disinfectant. This should not include the grill where the HEPA filter is, but it should include the work surface, the left and the right wall, the rear wall, and then the inside of the sash, all surfaces. Now you might say, Corey, my arms, they do not reach the back of that biosafety cabinet wall. And I will say a Swiffer can for you so that you can still use tools to reach areas in the cabinet that you may not be able to reach. Now, sash height is really important. Sash height is what helps with that face velocity. So when we certify cabinets, we're not just taking any random sash height, right? Often the cabinet will alarm, but people do like to silence alarms sometimes. So really check your cabinet, look for that arrow. There's always an indicator on these biosafety cabinets to tell you what the correct operational height is of that sash so that you are getting optimal protection as a worker. We talked a little bit about understanding the workspace. So really knowing in your cabinet when that air comes back and recirculating back into the cabinet, where does that curtain split? We want to be, we don't want to disrupt that air barrier if we don't have to, but ideally your samples are being placed right where that curtain splits, and that can change. Some manufacturers, the curtain is a little bit closer, some it's a little bit farther. So this is important also if you're training as well. Really be comfortable with the equipment that you have. Setting up your workspace. Now, I know sometimes you want to be really stingy with this and say you must work clean to dirty. I want to just provide a little bit of hesitation and flexibility with that. You want people to set up the workstation in something that's comfortable, for them and ergonomically comfortable for them, because you want to prevent crossing over and things like that. So it may mean that I don't like my waist on the right-hand side. I like it in the center and all the way to the back, because now I don't have to be crossing or moving my arms in wide sweeping motions. Instead, I'm just going front and back. So use this as a starting point, but do be flexible about it. But do put, if you do have aerosol equipment that does have a lot of aerosols, do put that towards the back, towards the rear grill, so it's being sucked in the back. But do be flexible about this with people, because you also don't want to force people to work in a certain pattern that is uncomfortable for them and potentially lead to incidents. So that grill in the front, super important, right? If we are blocking the airflow into the cabinet, it means it's just going to glide on by and straight into the cabinet. Or if you are blocking it, also means air can come now from the work surface. There's nothing stopping it, and it can come outside of the biosafety cabinet. So people resting their arms, or lab coats can do that. I'm sure we've all walked into a lab and seen somebody, put their SOP on the grill, because it is a really good spot to hold your notes because they don't move, right? So just kind of explaining that to people, you'll disrupt the air curtain. And yes, it means air can come in, but more importantly, it means air can come out. Some newer cabinets are really good at actually correcting this. and can self-adjust while this is occurring, but not the old cabinets. Movements inside the cabinet, understanding that you can disrupt that airflow. So trying to work, perpendicular in the cabinet and try not to swing out and swing in if at all possible is also really important to maintaining that air barrier and your protection as well. So I know that wasn't in great detail. We had a lot to cover today, but hopefully if this is of interest, we can have a more detailed conversation about this in future webinars. But I do want to just highlight a couple things. Anything I've said today, right, it's really important that you do your own risk assessment with your own stakeholders at your own entity. You know your entity best and your stakeholders know your entity best. You also know your people best. So sometimes we choose different procedures based on our personnel's experience in our laboratories or in our areas. So please take that into consideration as well. And just remember, just because you've done a risk assessment one time, it needs to be done over and over and over again, not just one time and we kind of move on. And then lastly, of course, the training is the most important part of this. We can have all this fancy equipment that protects us, but if we're not actually utilizing it right because we're unsure that we are maybe using it in a way that's we're losing protection, training really is the most important part of using these engineering controls since we are relying on them to protect us in the environment. So with that, I will turn over the slides.
Corey, thank you for that. That was such a comprehensive, review of biosafety cabinets, and I really appreciate that. Hopefully everybody has a little bit more understanding of what's appropriate for the work that they'll be doing. I do have a few questions in the queue, but question for you, you talked about maybe putting instrumentation within the safety cabinet. Mm-hmm. Is there concerns about the size of that equipment and disrupting that airflow?
Definitely. Yeah, fantastic question. Yeah, and sometimes even vibrations. Some people have really sensitive equipment where the vibrations of the biosafety cabinet. So what you want to do in that case is when the certifier shows up to certify your biosafety cabinet, you don't want it to be empty, right? Sometimes people clean it all out and they're like, ooh, it's shiny and it's new. But the reality is we want to know that our equipment is protecting us as we are going to use it. So go ahead and put that equipment in there. You want them to certify the cabinet with the equipment. Now, let's say you find out that maybe it is blocking a little bit too much of that back grill and air is not really getting around it. By just simply putting it on a little stage or a little stand, you then allow the air to keep flowing underneath it, and that could solve a problem. So yeah, definitely fantastic question. Put that equipment in there, ask them to certify the equipment with your, equipment that you're going to use every day inside the biosafety cabinet.
Great advice. Thank you. You kind of touched on this a little bit, but if you have a biosafety cabinet that's on wheels, can you actually move it without recertification, or how far can you move it? What are some of the rules?
Right, within reason. Yes, but that's why they're on wheels. And we see this on the research side too. We have a lot of, cage change stations and wheels. They're meant to be moved, right? But you do want to be careful. Like, are we talking we're moving it to a whole new building? Is it getting on a vehicle, that sort of thing? So within reason, I think if you're going over a lot of bumps, if you're going over, thresholds and things like that, that could dislodge that HEPA is where you might want to say, maybe we should have that recertified.
Okay, great. Thank you. Okay, I'm just going to read this one so I get this one right. It says, we are recording megnahelic pressure daily as a delta check on the function of the BSC. But according to what you had said, your talk indicates that that's HEPA filter quality. Are there other ways of tracking function of the BSC other than that pressure?
You're really, depending on the cabinet that you have, most of the time we're just relying on light indicators. Now, if you're worried about maybe airflow, you could, and this is we often see, taking some people like a visual indicator, like is the airflow going in the right direction? Just taking a small paper towel or a little strip of a Kim wipe and just putting a little bit of tape on the sash. Sometimes I see this in a lot of labs where they just like to know that the airflow direction is always going in. And that's just a really nice visual indicator. But you really are relying on the cabinet and the control panel to show you whether it's functioning or not. and the extent of what those functions are displayed are going to vary cabinet to cabinet.
All right. What would you use to decontaminate a biosafety cabinet? Again, knowing these are stainless steel, I think these are great questions.
Yeah.
And then there's questions about whether or not you should use spray bottles or not versus wipes.
Great question. This could be very entity specific, right? Some entities wear sprayers here, but that doesn't mean that's the only way. What you do want to be careful about, and thank you for asking this question and reminding me, if you are using a spray bottle, no problem, but don't be like an oversprayer, because you are going to create aerosols, right? And they're going to be sucked up into your HEPA filter. And then maybe your facilities people, or maybe the person who's certifying your HEPA may not be so happy with you, because it is a way to degrade your HEPA filter in a way, right? So yes, spraying is fine. Some people, and I see at entities, they don't want spraying in the cabinet. So they prefer to soak an absorbent, towel. Lots of people use Swiffer pads. They soak it and then they hand wipe. What you want to ask yourself, though, is, what's the purpose of this decontamination step that I'm doing? And is the method that I'm doing allowing enough contact time with that surface to decontaminate whatever I'm worried about? And the answer might be no. It's a problem sometimes we see with ethanol, right? Ethanol evaporates so quickly. Like, did I really get the contact time? Other things with disinfectants that you might want to keep in mind is, you're right, these are stainless steel, and what do? Rust. So if you are using maybe something that can cause rust, that's when you want to follow up with a second step of maybe ethanol or water to remove that residue so that you can prevent rust in these cabinets.
Excellent. Okay. So regarding like microbiological sampling of the air and surface, how frequently is it recommended to do that within your biosafety cabinet?
Yeah, I would say actual sampling is probably not something that's very common unless you're concerned with a contamination. But I will tell you, contamination is almost often always the user, just using the cabinet improperly or PPE improperly, where they're actually introducing contaminants from the room into their cell cultures. Or, you'll see there's a gap between their glove and their gown and their skin, is what's causing the staph or the strep or whatever it may be in there. So cleaning is really important. The most important part about that is understanding that the trays actually lift. And the tray cleaning underneath the tray is often where we see people don't do that. And that's where they start to get these fungal contaminations or other type of contamination. So we talked about cabinets should be disinfected before and after every use, right? But that's just general. You should have a cleaning schedule. So how often should I pick up that tray and completely disinfect under it? That may differ depending on the type of work that you do. If you're working in a really clean environment, you may not have a lot of debris, but if you have never looked under your work tray, I encourage you to do it. Just be prepared that you may find some dust bunnies under there. If you're working in an environment, maybe, with animals or other things where there is dander or bedding or things like that, you want to be cleaning under that much more, frequently than, I would say maybe people do it, once a week. I see some schedules that are once a month. It really is dependent on your situation.
Perfect. Okay. This is kind of open-ended a little bit. So is there a standard risk assessment template that you could use? And I think there's a lot of things that could go into risk assessment. So a little clarification might be.
Such a great question. I don't think so. I spend a lot of time Googling, though, and sometimes you can find some really nice risk assessments. If I have templates that I'm willing to share, it doesn't mean it might fit your situation. But I'm, happy to share. It is really hard finding templates that are really widely available for what we do.
Yep. And I think the question is, are you doing a risk assessment based on the samples that you're using or the procedure or so there's a little bit more that goes into that.
Yeah. I mean, you could probably make some of them a little bit, step back a little bit and make them a little bit more vague. But, information changes. What we know about agents, may change. Situations change. Personnel change. So I think, having an overall risk assessment is good because you want to have a starting point with the realization that, when this instance actually does happen, we may need to do a real-time risk assessment quickly at that moment.
Um, One person is asking, have you found a good alternative to the Bacti incinerator since it may generate heat and may alter airflow?
Oh, I'm a microbiologist, so I love sizzling in loops. There is, I encourage you, if you haven't, Baker makes some really great Mythbuster videos, and some of them include disruption of airflow with, heat and flames and stuff in a biosafety cabinet. So I encourage you, and I don't have any ties to Baker, by the way. I really enjoy their videos because they're science and they have all of this data, and they have some really great biosafety cabinet mythbusters if you go on their website, and that is one of them. And some of them they have disproven what we think our feelings say, right, about what we think disrupts biosafety cabinets may not always be true. So I encourage you to take a look there.
All right. Thank you. That is all the time that we have for questions, but I thank each and every one of you for being here. I want to thank Corey for her incredible knowledge on this subject and for agreeing to do this webinar. It was fantastic to have you on. You can submit technical support service requests to NETEC if you have more questions or need any kind of support at netec.org. Or you can email us at info@netec.org, and we will make sure that your question goes to the appropriate subject matter expert. So with that, I would like to, again, just thank everybody for being on. I'm so glad that we were able to do this for the lab, and I look forward to maybe doing some future webinars with you again, Corey, and learning some more information. Thank you all. We will see you next time. Thanks.